Now we've got a continuum of these perturbing frequencies from the electromagnetic wave. We'll need to sum over this range of frequencies, and let's assume that the omega is varying smoothly, so we won't be summing, we'll be integrating, right? So effectively we'll be integrating over this for the range delta omega. Okay. Now if we're talking a continuum of omega, we can, like as mentioned a bit earlier, previous session, we can bring in a density of, or it's called the intensity in this case, of the radiation at a particular frequency or omega. Okay. So then to get this contribution AM squared, we will now integrate over the range where your omega ranges from delta omega. So let's assume it's 0 outside that range. So we're not applying a pure single frequency in the electromagnetic wave that's perturbing the electron in the atom. Right? There'll be a range of frequencies, and the intensity, sort of like a density, it's the same thing, at a particular frequency, we'll call it I. Right? Now the rest here is the same, except there's the threes come out here, I guess. So let's go. So the flux, the half eta E naught squared, eta E naught, whatever. Yes, something I'm not quite following here. So the relevance of this flux, talking about the flux here, and it's obviously been brought in here, but the text didn't. Can you follow that yourself? So you've got so the E naught here is no longer here, right? And you've got a C. So we're bringing in the flux, this discussion here to here. That wasn't clear to me, and I haven't thought too hard about it. Like I say, this stuff now at the very end of the text is really just getting thrown at you, just to give you a feel. Anyway, so glossing over that. So you now have a you're integrating this term. You're summing effectively these terms for a range of omega at a given intensity or density, if you like, same thing. So you're putting this term, here's your contribution, and you're adding them all, in this case integrating, because we're talking continuous. Right? Now, again, similar reasoning as before, this sine squared term is sharply peaked, right, around omega, when omega equals omega mk. So this will be sharply peaked. So effectively, these other terms, which vary much more slowly as omega, as a function of omega, so you can bring them outside the integral, and well, it's effectively the end of the session. I'll need to continue on in the next term, the next session. So I'm feeling somewhat frustrated because there's just getting a lot more now between the lines, and not so clear. That's why in some ways I prefer mathematics, because the mathematicians insist on step by step, so things are clear from one line to the next. Whereas the physicists tend to do this kind of... I mean, the priority of physicists is different from what the mathematicians are doing. Mathematicians are essentially logicians, and so they don't like jumping steps. They like a logical progression, step by step, in proofs and so forth. Whereas physicists, their task is different. They're trying to understand the world, right? So its logic is less essential. It's still very important, of course, because you're mathematically modelling. But the top priority is understanding the world. So intuitive leaps and jumps to try to understand how nature is an essential component in being a physicist. So the two motivations are different, and sometimes there's a clash. I can remember a famous little exchange conversation between Dyson. Dyson was one of the major figures in the development of QED, quantum electrodynamics, and he worked with Feynman, one of the main guys in the development. Got a Nobel Prize for his work on the development of QED. That's Feynman. And Dyson had a friend, and I guess they were grad students at the time, or postdocs or something. And Dyson's friend said to Dyson that he wanted to do research in pure mathematics, that he didn't like physics because it was so untidy. That was his word. And Dyson replied that's precisely why he wanted to do physics, because it was so untidy, that involving these intuitive leaps, and it wasn't clear which mathematical models should be applied to particular physical situations, stuff like that, in that sense of untidy. So I'm getting increasingly frustrated that the amount between the lines now, a lot of jumping, it makes the mathematician in me feeling rather antsy.